So, hello everyone. They just put the fan here, so you have to excuse me if it makes my hair look awesome. I always wanted to be a rock star, so I can like pretend that I am, but like Steve Vai himself. But I'm not. My name is Albert, and I'm a CTO of Webhuset, is a company. We are located in Gothenburg, Sweden. We are currently, I think, 26 humans and 1 dog in the office. We work with e-commerce mostly. We do some other things as well, but our bread and butter is e-commerce websites. Magento is the system we are building on. Maybe some of you have heard it. It's built on PHP, a really large, one of the biggest open source e-commerce platforms. We started 2 years ago with Elm because we wanted to build a better user experience for the people shopping in the e-commerce. So we actually built a complete single-page application front end for Magento, and currently we have 6 of them in production. So I'm quickly going to show you some of the things we did so you have an idea. So this is a website that sells rings, like a normal e-commerce website. You can find the diamonds, add them to your ring. Yeah, maybe too cheap. Maybe we should have a more expensive one. And everything here is like routing is done in Elm, and we are fetching things from the backend, only data. It has a lot of content as well. Another site, it's selling sports clothes for women. So it's similar. Not going to spend too much time here. Another site with, yeah, so you recognize basically a standard e-commerce solution. About 60 to 100,000 lines of code for each of the application. Depends on how you count, but somewhere in that size. About 40–50% of the code is reused between all these different applications, something like that. We use Elm UI for all the front-end parts, so no CSS or stuff, and it's really nice, I think. It helps. Like, I'm a back-end person from the beginning, and now I can make things be in the middle vertically. In like, I couldn't do that before, so it's amazing. GraphQL to all the communication with Magento. We built a GraphQL endpoint on top of Magento, and then we use that to fetch all the data to Elm. A lot of pages have a lot of content as well. It's not only products. And we use basically markdown files, render them, parse them, and render them with Elm UI. So the clients, they have to write markdown currently. We have some other ideas for that in the future, but all the sites are multi-language, so everything is translatable. All the strings and content of every site can be translated. So what are the challenges of working with 6 single-page application in this size with 20 programmers? One thing that is really difficult is testing, because we have built one monolith application, and you have to run the application for most part to test things. Of course, you can write like the quick check tests for functions, but that's not really what you need to test in this context. It's probably you want to test UI. How do you do that in quick check, for example? We have a really hard time estimating, so that's something that we always have to do when someone is paying for our work. They want to know how much it's going to cost. And it's really something we struggle with this huge application. it's hard for newcomers to understand, or maybe not hard, but it's harder than what it should be. That's probably mostly our own fault, because how we ended up doing things. It's also difficult to scale when you have a large application, because you tend to get in each other's way all the time if you're 5 people trying to solve a problem together. So that's something that we struggle with. And also we feel the code base is, I would call it, unpredictable. So you think that, okay, I can change this, so it would mean going here and there and there. And then when you start doing it, you realize it's like, oh, this one was connected to this one. And Elm is really helpful. I mean, you can work with an unpredictable code base, but it takes a lot of time, and that's the problem. So the compiler, it tells you, yeah, you change this, you also have to change these other 500 things. And well, I said I was going to be done tomorrow, so now I have a problem. So things work, but they take time to maintain if you have an unpredictable code base. Okay, so we started maybe half a year ago or before Christmas sometime to think about what we can do to improve. So now everything is there, it works, it's in production. We should think about how we can improve our way of working. And so basically, this is not our idea. Someone else came up with this, but we have this big application, and we thought, what if we do this? You can call it microservices, or we call it the actor model, or take inspiration from the actor model. The Unix philosophy, there is a lot of names for the same kind of idea. And that is taking one large monolith application and breaking up into several smaller applications. That each application has a very defined responsibility, so that when you try to figure out how it works, you can like forget all the other things and focus on one thing. So this is what we wanted to do. And there is something called component-based development. So it's basically you break the problem or the requirements down into components. You put them out on the table, you discuss them, and maybe we have a router, maybe we have a page layout component or something like that. I'm not referring to what you usually mean in the context of React when you say component. Here I'm talking a bit more abstract or generally. So, and then once you have figured out how you want to solve the problem, you start implementing components and you test them. And you do that outside the application. So you have an environment where you can test and build. And then you start putting things together. Of course, when you try to break it down, you don't always get it right, but you will get it 90% right if you spend some time on it. And implementing components is something you can easily scale, because once it's well defined what the component is, you can just give one component to each person and they go home and develop it and come back when they're done. So you don't get in each other's way as much. Okay, so this is what we wanted to do, and we started thinking about the actor model. I'm not going to talk too much about what the actor model is, but think of it as we have many Elm applications that send messages to each other. You can conceptually, think about it like I make ports and I send data between all these applications. That's not how we do it, but conceptually. So you take an application or a design sketch or something like that, you break it down. So here's an example of a few things to break down. Maybe you have a tags component, an article list component. Then you have some components that are similar to the platform worker. They don't have any UI, but they do something, maybe talk to the backend or parse the URL or they have a single responsibility. Okay, so how does a component look like in Elm in the way we are working with it? You all know this, I hope. Can you see in the back? Yeah. So this is the browser element application. You should be familiar with it. So what we did is basically this. You see that the return tuple of the init and update function have become a triple, or what did you call it? Yeah. With a list of out messages in the middle. So this is a common pattern, I think it's been used before. So this list of out messages is the way that these applications can communicate with each other. So it's an Elm type, a custom type, the same as the in message. So I'm going to show a little how it can look like in code and how we work with it. So as I said here, we have a tags component, for example. We have identified it. So we start just writing down simple markdown file, trying to explain what is a tag component. So we put some responsibilities on it, or requirements, just describing what it does and what it shouldn't do. We write down some interfaces, just trying to explain, yeah, this is what data we need to get into this component, and this is what it will send out. So in this case, you have to give it some tags, and you might give it an error, because what if you cannot load the tags or something like that? And you send out a message when you click on a tag. It also has a message here that basically saying, hey, can you give me some tags? That is when the component is initialized. Yeah, some screenshots and maybe HTML. So this we do for every component. So here is the real world example, the conduit app that I have broken down into components. So we need this many components to build this up, and you can look at them, try to understand what they do. Then it's time to implement the components. So basically what we do is, yeah, you see the messages are here. We have the in messages, which is the just called message in a normal Elm application, and we have the out messages. You have a model. We have a component, which is basically the record that we compose together to the application later. You see the init function when the app or the actor is started, it sends out the message saying, hey, I need some tags to render them. You can skip some things here. You have subs or subscriptions, same as in Elm. You have an update function, same as Elm. But you can also, in the middle, send the out message when something happens. And then you have a view function where you render some HTML. So this shouldn't be very different from what you're already familiar with. Then to test this component, we have built a library that is used for putting components together and testing them. So every component has a sandbox file. So it's just the same name, but with sandbox in the end. So you have a sandbox file for the tags component, where you basically, here is one test case, for example, for the sandbox. You have an initialize where you can send some messages to it. You have a handler for the out messages where you can pass the test, fail the test, send other in messages. So it's basically emulating the rest of the system in a very simple way, or mocking it. And then you just go to this file in Elm UI. Just click on it. No, not Elm UI. Elm Reactor, sorry. And it will instantiate many of these applications. So each of these white boxes is a sandbox. And I had defined several test cases. You see the messages in and out down here. Then we have the error state of the component. So all my test cases, you can just scroll them through. And if you want to work with one test case, you can display it in some different ways. For testing UI, it's very useful when you want to, for example, render the instances of the component next to each other, and you can easily see here that if we get a very long tag name, it will break. So this is the way we test UI components. Just have a quick look at it. For service components or components that doesn't have any UI, you can attach these pass and fail events, and it will be shown here. Okay, so sometimes, or most of the times actually, when you develop something, you usually start by making it work. So in our case, we make the tag component work. So when I click a tag, it sends a message out, as you can see here. Here I have some UI test where I can actually have to click the right tag for the test to pass. So now it works, but probably you want to do something after that. You give it to a UX designer or someone to make it a bit nicer. So I had some examples just to show you. So for example, when the tag is ticked, it should flash and give you some user feedback that it has been clicked. And how would you implement this in... so basically you have a... your component is a normal Elm program. You have your update functions. You have your states and commands. So you can just add a timeout and doing some rendering. So I will do this now. So the thing that I did was just add a set of the tags that have been clicked. I added some messages. When the tag was clicked, I send a timeout for 200 milliseconds. And then in the view function, I add a CSS class when the tag was clicked, and then I wrote some CSS. You see how fast it was to develop that. So now you see, maybe this is not awesome from a UX perspective, but I just wanted to show that you can continue developing this component. And since it is a complete Elm application, you have available subscriptions and you have available the messages or the commands, which makes it easy to increase a component's complexity without having to make the one using the component more complex. The last thing I want to show you is a little on how you put these components together. So I have a file here to the right where we have two functions. We have a map-in function and a map-out function. So we can start with the map-out functions. So basically, I just say here, what should happen when the component sends the out message, give me tags? Well, it should send a message to the article service component, sending its own process identifier, or PID. So you send a message there and expect the message to get back to me. And in the map-in function, you can see that when I get the tags message back, I can either, if it was working, I send an in message to my component that I got the tags, or I send an error to my component that something went wrong. So this is basically what you do when you put components together. You connect the arrows between the circles. So one last thing. So, for example, this page component that you see here, it actually renders the list and the tags component inside it, and I haven't showed you how that works. But it's quite simple. You have a page component. Maybe it could look like this. You have a model with header, footer, and content PID, or process identifier. The view function of this component, we call it a layout component when it has this type signature in the view function. you're given a render function or a function that takes a PID and returns HTML. So you can do this, for example. You render the PIDs from the model inside the so you can build a layout component that doesn't know anything about what is inside each of these areas. So this is a very simplified example. So all this is published on Elm packages. It's still a bit in development, so we're using it ourselves for some new projects, and we're trying to break this old project up. But the package is Elm Actor model, so you can actually start using this. It is a bit lacking some of the documentations and examples, so I have started making the same real-world example application that already exists for Elm that Richard Feldman made, but in this architecture, to have something to compare, like how would it look like in this architecture, and how would a new requirement, like how much code do I have to change, or something like that too. Yeah, that's all for me. Thank you very much.
Questions?
Thank you very much. How does it work, the communication between those components? Do you actually have types that are shared between those messages that are sent across?
No, we try to avoid sharing types as much as possible. So this is the message type of my application, the global message type. And as you can see, we basically wrap all the in messages of every component into one single type. And that encapsulates the communication between the components. So when you map an out message, it becomes this global message type. And when you get an in message, you have to unwrap it or case match for the messages that you want to be able to handle in your component.
Do you lose type safety with that? Did you find any problems with
you don't lose type safety, but you could make mistakes that the compiler won't catch. For example, if I forget to do this part of the code, it will not receive the messages, but we will log them out when you're in debug mode or in the sandbox mode. So it will log that, oh, you haven't handled this message, for example. It's very easy to catch this kind of errors, so it hasn't been a huge problem so far. We are thinking about how to make this also a compiler error, but it's tricky to actually make it work.
Sorry, I have a few more questions, but I guess the question I wanted to ask is, like, if you have complex structures, let's imagine a JSON object, you would have to convert that to string or some core implementation, then to probably decode it again on the other side. Does that happen ever? I guess it's the same question, but...
Yeah, we don't do JSON between the applications, so it looks like you're building an application in your component, but it actually gets put into one browser element or browser application in the end, so it doesn't need to encode and decode the messages to send them between applications. It's just basically a library that is the runtime for this. Everything done in Elm.
Would it make sense to expose those components as separate libraries or things that you can use in your own?
Yeah, so that's what we have been thinking about, because we realized the more things we build, I don't know where that slide went, but yeah, for example, the router, we tend to do the same router all the time. Like, there is not many ways of doing it. So maybe that could be a package with maybe you have 3 different ways of doing routing or page layout or other common things.
Okay. The last
Authentication is another one. That is.
Last question, I promise. How does the render PID work? Does it have like a global dictionary that you look the interface on?
So that's your last question. I'm sorry, but
Yeah, every process is stored in a dictionary, and when we render it, we just get the model from that one, render it, map the types to the global message type, and compose it.
so we can have one more question.
So when you have out messages and you interpret them, how you make sure that you don't have forever loop, so that out messages don't produce some new in messages that will produce out messages that will. So how you make sure that you don't get into the infinite loop?
Yeah, so it's the same question as if you make a recursive case function on a list or something like that. It's very easy to get into an infinite loop if you do it wrong. And it's the same thing here. So if you send a message to yourself and you keep sending, so there is nothing in this architecture that prevents you from doing it, the same as there is nothing preventing you from doing a recursive function that runs forever.
Okay. So thank you very much for this presentation. We won't do a break. I'm sorry, but we are short on schedule. So, but after that we will be able to eat something. So thank you very much, Albert.
Yeah, thank you very much.